Welcome. So in this video, we are going to see how we can write some code to access an array using pointers mostly. So the first question says to modify the question week 1.1 to print the address of the variable sum. And there's some hint given. The address can be known by typing the ampersand symbol along with the variable name. So you will find this code under your week 1 shell in the week 1 section of Moodle under this particular folder. So I'll download this code and I'll open this code with Notepad++ or Notepad. Right, so this is the code that we have, and now I'll create a project in a Visual Studio 2019. Click on create a new project. Once again, empty project with the C++. Next, I'll call this exercise 1 and I'll save it in my lab folder. Select folder and click on create. So once again, we will right click on source files, go to add and click on a new item to create a new empty file, C++ file. I'll give the name as main, add, and then we get a empty workspace. So I'll copy this code from Notepad and paste it in my Visual Studio. So what this code is currently doing is there's some definition of some variables, float a, b, and sum, and then it is asking the user to enter first number, and that is stored in variable a. Then it is asking for a second number, which is stored in b, and then we are finding the sum of those two numbers and storing it in the sum variable, and then at the end we are trying to print the value of sum. So I'll run this code to see how it behaves. So it says enter the first number, let's enter 4, second number 5, it says the sum of the two numbers is 9. Now the question says to print the address of that variable sum. So to print the address, we can just simply put this ampersand symbol, and now we will not get the sum anymore, we will get the address 4, 5, and it says the sum of the two numbers is, and this time we don't get the sum, we are getting the address of the place where the sum is stored in the memory, right? Okay, so let's say this is our memory of our computer. So these are the addresses of each block of the memory. So let's say the first one is 0x1234, then 0x1238, and so on. And these addresses are in hexadecimal numbers. So when we define a variable, if I say float a, right, then what happens is in the memory a place for that variable is created. In our case, let's say the variable is created at this particular location, right, that is 0x1246 over here. Then when I say float b, then a space for b is created. Let's say this is the one, and then we had float sum. So again a place for the sum variable is created, and in this case the sum is over here, right? So when we take the input from the user and the user enters some value for a, that value is stored at this particular location, right, where the variable a is, and then for b it is stored in the location for b. Then when we do the sum is stored in this area. So when we do a cout sum, we get the value of the sum variable, which is 9. But if I say print ampersand sum, then in this case what we will get is not the value but the address where that sum is stored. So in this case we will get 0x1254. Right, so when we use this ampersand symbol, we will get the address, and if I don't put the ampersand symbol, just the variable name, we will get the value of the variable, which is 9. So in our case, we are getting this particular address. That means we are getting the address of the memory where the value of sum is stored. Then the second question says, modify question week 1.8. Create a new float pointer. So I'll first download this particular code. So once again, you will find this in that same folder, week 1.8.cpp. I'll open this in Notepad++, and then copy the code and paste it in my Visual Studio. Now you can create a new project for this, but I'll use the same one. So before we do the actual work, I'll just indent this code so it looks neat. Okay, so my code is formatted. Now let's see what this code is doing before we implement our solution. So it is declaring a constant variable of type integer whose value is initially 10. Then we have float AB sum, and sum is initially 0. Then we are trying to create an array of size 10, which is maximum size. The array is of type float. That means we can store decimal numbers, that is the floating point numbers, in this array. And then we have a counter variable. Initially the value is 0. Then we are trying to open this file called numbers.txt, and then just checking if the file is open. So if the file doesn't open, then we print this message. Otherwise we go on to reading the file, right? So again the counter is 0. Then we are trying to read a value from the file, right? The file variable is in. Then we are reading a value from the file and then trying to store that into the array. So we are reading the file as long as we are able to get a value from the file, as well as the counter is less than maximum size. That means while there is some space in the array. So after reading the value into the variable I, we are multiplying that number by 2 and then storing that number into the array at index counter. So initially the value of counter is 0. So the number is stored at index 0. Then counter increments and becomes 1. Then we read a second value. Then store the value at index 1, because this time the value of counter is 1. And then continue doing it until this condition is true. And then after reading, we display a message saying the data was read from the file. And then we are trying to print the values from the array. So we traverse the entire array from 0 all the way up till however number of elements there are in the array. And then we are doing a cout array at index I. And then at the end, we are trying to print the number of elements that are there in the array. So it says the total number read was counter. So I'll run this code and see what happens. It says file could not be found. That is because we don't have this file at the moment, numbers.txt. So what I'll do is I'll create a file in my project folder. So my code is saved in my lab3 folder. So I'll go to exercise 1, again exercise 1, and where I have my main.cpp, in the same location I will create a text file. I'll call this numbers.txt, and we'll just save some numbers in the file. Let's say 6 numbers. Close the file, go back to the code and run the code once again. So it says the data was read from the file. The double of values read are 2, 4, 6, 8, 10, 12. So notice that we have stored numbers 1 through 6. And since we are doubling the number when we are storing it, the numbers become 2 up till 12. And it says the total number read was 6. Right? There are 6 numbers in our file. So that is what the code is doing. And now what we have to do is do the same thing, but this time using pointers. So it says create a new float pointer, say ptr float array, to fill that float array instead of directly filling values using the array. So right now what we are doing is directly filling the values into the array using the indexing method, right? And now instead of using the index, we have to use pointers. So there are some code given over here. We can use this piece of code in our main.cpp. But before that, let's see how the code is going to work. So what we did in here was we created a constant variable max size of size 10, and then we created an array of that same size. So we had an array with 10 spaces, right? Something like that. And then we had the array indexes from 0 all the way up till 9. Right, so the size of the array is 10. So the indexes will go from 0 all the way up till 9. And the name of this array was double array. We also had a counter variable, which was initially 0. And then we used this counter variable to update the indexes of the array. So initially the value of counter was 0. And then we read the value from the file. We multiplied the value by 2 to make it double. And then stored that value at index counter. So that value goes at index 0. And then we incremented the counter, so counter became 1. Then next value was stored at index 1. So next value came at index 1. Then again counter became 2. And in the same fashion, the values were stored in our array at these indexes. And the value of counter eventually became 6 because there are 6 values in the array. Now this is one way of accessing the array, either to store or get the data from the array. The other method is to use a pointer. So it says to create a pointer and name it ptr float array. So we have a float, ptr float array. It says to declare a pointer to point to float array. So what we'll do now is we'll create a pointer. Now this array that we have here is of type float. That means if I want to use a pointer to update this array, then that pointer should also be of type float, right? If the array was of type integer, then the pointer will also be of type integer. So since in our case the array is of type float, right? Don't confuse this with the name of the array, right? This is not the data type, this is only the name of the array. The type of the array is float. So we'll create a pointer of type float. Let's call this ptr float array. Now what we have done here is just created a normal variable of type float. To make this a pointer, you will need this asterisk symbol over here, right, between the data type and the name of the pointer. So now this variable ptr float array is a pointer variable. So that is the first part. The second part would be to make this pointer point to the array. Right now the pointer is not pointing anywhere, right? So to make this pointer point to the array, that means this pointer must point to this first location. Only then we will be able to update that particular index of the array. And to make this pointer point to that particular index, we will have to initialize this to the name of the array. So the name of the array is double array. So we will say double array. So when I do float ptr float array equals double array, what happens is this pointer is now pointing to the array at index 0. So now since our pointer is pointing to the first index, we can use the pointer to change the value of the array at the first index. And we know that to use a pointer to update the value of a variable, we will have to use the dereference operator. So for example, I'll give an example here. Now suppose I have a variable, let's say sum. Let's call this int sum. Initially the value is 0, and if I want to use a pointer to set the value of sum, what I'll do is I'll have to create a pointer int. So notice again, the type of the sum variable is integer, so the type of the pointer must also be integer. Asterisk, and let's call this maybe ptr, and to make it point to this variable sum, I will use the ampersand operator because the pointer stores address. Now one thing you might have noticed over here is, in this case, for the our float array, we are not using this ampersand symbol over here, right? So that is the difference between using a pointer with the array and a pointer with a normal variable. When you are trying to make a pointer point to an array, you will not use this ampersand symbol, because what we are doing is, when we create an array of any type, what we are actually doing is creating a pointer. So you can say kind of that an array is a pointer. That is why we don't use this ampersand symbol over here. But when you create the pointer to a normal variable, you will need the ampersand symbol, because a normal variable is not same as an array. Okay, so now if I want to use this pointer ptr to update the value of sum, what I will have to do is I will say ptr is equal to some value. Now we cannot do this because we are trying to assign the value to the pointer, and we know that a pointer stores the address, and this is not a address. So to assign the value to the variable sum, we will have to use the dereference operator. So now what we are saying is, you assign the value to the content of this ptr, and what this ptr holds is the address of this variable sum. So let's say this is our sum variable at some index in the memory, 0x12 maybe. Then we have a ptr. So the address of the sum variable is 0x12, and let's say the address of this ptr is 0x14. Then next one is 0x16. Now the sum variable has the value 0 because we have said sum is equal to 0, right? And then we are saying int ptr is equal to address of sum. So what happens over here is, this pointer is now pointing to the variable sum, and what happens inside the address or the memory is, the value 0x12 is stored, and this address is the address of the variable sum, right? So a pointer variable stores a address, right, of some other memory location. So when I say contents of ptr equals to, what we are doing is, we are going to this variable ptr, right, and then we are going to its content. So ptr has the value 0x12, so we go to this particular address, and 0x12 is over here. So in that address, we are assigning the value 2. So the variable sum is now equal to 2. So the takeaway is, when you want to assign the value to a variable using a pointer, we need to use the dereference operator. Now going back to our array. So if I want to assign the value to the array index, what I will do is I will say ptr underscore float underscore array, which is the name of our pointer, equals some value. Now since we are using a pointer, we need to use the dereference operator. So when this line executes, what will happen is, the value 2 will be stored at index 0. Why index 0? Because the pointer is now pointing to the very first index, which is 0. Then what if I want to store the value at the second index, which is over here? So in that case, I will have to shift this pointer from the very first index to the second index. And to shift the pointer, I can simply say ptr float, right, the name of the pointer, and I will say plus plus. So what will happen? When I increment the pointer will start pointing to the next memory location. In this case, index 1. So now if I do ptr float array equals 4, the value 4 will be stored at index 1. Then to go to the next index, I will again do ptr float array plus plus. Now the pointer is pointing to the third location. And then to assign the value, I will execute this line. So in the same way, we can traverse the entire array using the pointer. Now going back to our question, it says we have to declare the pointer variable. So I'll just copy this line and paste it in my code. So I'll create a pointer variable of type float. Then to make it point to the array, I will write this line. So the name of the pointer equals the name of the array. So in our case, the name of the array is double array. So I'll change it to double array. So over here, we have created a pointer variable, and then we have made the pointer point to the first location in the array. And then we have to use the pointer to update the indexes or the values of the array. So the place where we are reading the data from the file over here. So now instead of doing something like this, what I will say is content of ptr float array is equal to 2 times I. So now this value is stored in the array using the pointer at the very first index. Now how do we go to the second index? We can just simply increment the pointer. So I will say ptr float array plus plus. So this will shift the pointer from the first index to the second index. And then we will go back, read the value, and now the pointer is pointing to the second location. So now the new value is stored at the second location. And then again we will increment the pointer, and in the similar way we will traverse the entire array and store the values using this pointer variable. Now I'll run this code for now to see if there are any errors. Okay, so the values were stored. Now I'll go back and make some more changes. So in here in the for loop, we are still using the index to get the values. And now I can use the pointer. So you can use either of the methods. So I'll write this same piece of code once again. And instead of using the indexes, I will use the pointer. So I will say contents of ptr float array. Now if I run this, you will notice that we don't get our expected values because there is a logical error in this code, and I will tell you the error after I run this code. So what do you see? We get some random values. We don't get the values 2, 4, 6, 8 and 10 and 12. And why do you think this is happening? We'll see that using the debugger. The total number read was 6, so we have read all the values, but we don't quite get all the correct values. So what I'll do is I'll run the debugger. I'll press the F11 button on my keyboard, and I'll add the some of the variables in my watch window. So I'll add the ptr float array, which is the pointer. I'll add the double array, and I'll also add each of the indexes of the array. So what I want to see is the address of the array at each of the indexes. So I'll say double array at index 0, right? I want to know what is the address of the array at index 0. And then in the similar way, I'll add the remaining indexes from 0 all the way up till maybe 6. Okay, so I have added the pointer, the array, and then I want to also see the addresses of the array at these indexes from 0 all the way up till 5. Right, we can add the remaining as well from 0 to 9, but we don't need all of those because we only have 6 values to store. And now I'll run the debugger. Right, so I'll step into the code. So the value is initialized to 10, maximum value or maximum size, and then we are going to line number 16. So when this line executes, the value of this pointer variable, which is this address, will be the same as this value, which is 003CFB14, because the pointer is pointing to the first index of the array. Right, so you will notice that the values are now exactly the same. And then we go further into the code. So we try to read the values from the file. Right, so the value was read in the variable I. I'll add I here as well. Right, the value of I is 1, and that 1 is coming from the file. So now we are trying to assign the value 2 times 1, which is 2, to wherever this pointer is pointing to. That means in this double array, the first value should be initialized or should change to 2. Right, so notice what happens at this index. So the value is now 2. The second index of the array, which is index 1, has the address 003CFB18, and the value at the moment is not initialized. So I'll run this loop once again. Next time when the value is read, right, so you will notice that when the pointer was implemented, the value has now changed to 18, which is the value of the second index of the array. Index 1, the address is 18, right? And then now the value of the second index will change. So now the value of the second index, which is 18, is now 4. And how this 4 came here was because the pointer, this ptr float array, was pointing to that second index, right? And the value was changed to 4. And then when this line 34 executes, you will notice that the value of this ptr float array will change to 1C, because the next index is 2, and that is the address of 1C. So this value of ptr float array will change to 1C at the end. So now it is 1C. That means the pointer is now pointing to this particular index, which is index 2. And in the similar way, the entire array, or at least up till the index 5, is updated. Right, so now the last index, which is not the last index, but the index of 5 of the array, has now the value 12. Then we go further into the code. So now we are at the for loop. Now notice where the pointer is pointing. It is pointing to address 2C. And where do you think that 2C is? Well, that 2C is the index 6. So if I print So if I add the index 6 to the watch window, you will see that the address is 2C, and that is where our pointer is pointing to. So when we go into this for loop and run the code, so it is trying to get the content of the pointer, right? And the value that we get is some random value, which is this value at index 6. And that is what we are getting on the screen, right? You will notice that we have negative 107374, right? It's just in some different notation, but the value that we are getting is from this index. What we should be getting instead is this value 2, which is at index 0. but we are getting the value from index 6. That means our pointer is getting the value from where it was last left off. So in this while loop, our pointer was pointing to index number 5, right? And then when we increment that, right, the pointer was pointing to index number 6. And then in the for loop, the pointer is trying to get the value from the same place where it was last pointing to, which is index number 6. But we want the value from index number 0. So to make the pointer point to this first index, we will have to reinitialize the pointer. And to reinitialize, we will again have to say whatever we did over here. So we will say ptr float array is equal to double array. So when we do that, the pointer will point to the array at the very first index. So I'll run the debugger and I'll run the code once again. So this time you will see that we get only values 2 all the way up till the index 5. And that is because in the for loop, we are only getting the value of the pointer at only one index. We are not incrementing the pointer. That means we are not shifting the pointer to the next index. So to shift the pointer to the next index, we will have to increment the pointer. And to increment, we will just do plus plus, same as what we did over here. And this time, finally, when we run the code, we will get our correct values. So now we get 2, 4, 6, 8, 10, 12. So in summary, we are creating a pointer variable and making it point to the first index of the array. Then in the while loop, we are reading the value from the file. And then using the pointer, we are trying to store the value into the array. And then after storing, we make the pointer point to the next index in the array and continue doing this until all the values are read from the file. Once the values are read, we go to the next part of the code and we reinitialize the pointer to the first index, because in the while loop, the pointer was pointing to index number 6. And to get the values from the very first index, we need to make the pointer point to the first index. And to do that, we reinitialize the pointer to index number 0. And then in the for loop, we get the value of the pointer, and then this will print the value at the first index or the place where the pointer is pointing to. And then after we have got the value of the pointer, we increment the pointer using plus plus to make the pointer point to the next element. And then we continue doing this. So that was question number 2. Then question number 3 says modify question week 1.7. So I'll download the question 1.7. Open this in Notepad++. Copy the entire code and I'll paste it in my Visual Studio. You can create a new project. So what we have here is we have the same code from the first part that we did. We are reading value of a, b, and then we are finding the sum. And along with that, we also have 2 functions. First one is do sum, and that is taking 2 variables or 2 parameters, a and b. The function definition is over here, and it is returning the sum of a and b. So I'll run this code and see what happens. Enter first number 4, second number 5. It says sum is 9. So what we have to do is modify the program to use a pointer instead of passing a variable by reference in a function. Do sum by reference, and the function prototype will look something like this. Now what is happening here is we are calling this function do sum by reference, and we are passing this sum variable by reference, because if we don't pass it by reference, then whatever happens to this variable sum will not be reflected in our main function. And now instead of passing by reference, we have to pass by pointer. To pass by pointer, we have to use this pointer symbol or asterisk, and do the same in the function definition. So at the moment, if I run the code, then this is not going to run, right? We get some errors. So what we have to do is we want to change the value of this pointer variable to the sum of I and b. So to assign the value of I and b, the sum of I and b, we have to assign it to the content of the sum variable. So we will say the content of sum is equal to the value a plus b. And still, if I run this code, this is not going to run because there are some errors. And the error is that we have to pass this sum variable by reference. And why is that? So we know that a pointer variable takes the address. So when we pass the sum variable, we have to pass the address. And to get the address of a variable, we use the ampersand symbol. So when we do ampersand sum, the address of the sum variable is passed to this pointer variable. And then in the function, we are using that pointer variable to update the value of sum. And now when I run the code, it compiles, enter 4 and 5, we get the sum as 9. Then question number 4 says to modify the question 1.9. So I will download the question 1.9. Once again, open in Notepad. I'll copy the code and paste it in my Visual Studio. So this code is same as that we had in exercise 2 using the pointer with array. So what we have to do is use a pointer instead of the array in the argument of the function sum of double, and the function prototype will look something like this. In the code, what we are doing is passing the array to the function, right? Float double array, and we are passing the array. So instead of passing the array, we have to pass a pointer to this function and use the pointer to get the sum. So if I run this code right now, right, we get the values from the array, and it says the sum is 42. And at the moment, it is using the array itself to get the sum. If I look at this sum of double function, we are passing the array, the size of the array, and inside the function, we are going over the array and we are trying to find the sum. And we are saying sum is equal to sum plus the value at index I. Now instead of passing this array, we have to pass a pointer. And how do we pass a pointer? So we'll have to first create a pointer of type float, since the array is of type float. So we'll call it a ptr array maybe, and we'll initialize that to the array. So we'll make it point to this array. So this pointer is pointing to the first index or the first element of the array. Then in the function, we have to pass the pointer. So I'll remove this array and replace that with the pointer. Right, I'll do the same thing in the function implementation. So now the function is taking the pointer. Now, how do we use the pointer to find the sum? So I'll remove this particular line, right? We don't need this, but I'll leave it inside the function. So right now the pointer is pointing to the first element of the array, And in here we can say sum is equal to sum plus the content of the pointer. So at this point, when this line executes, it will get the value from the very first index of the array and add it to sum. But after this, we have to make the pointer point to the second element. So to do that, we will have to increment the pointer. So ptr plus plus. Now the pointer is pointing to the second element. Then we again get the value of the second element and add it to the sum variable. Then again increment the pointer. So we continue doing this until however number of elements there are in the array, which is size. Now how do we pass the array or the pointer to the function? So the place where we are calling the function, which is here, so instead of passing the array, we will pass the pointer. So now let's run the code and see if it works. Okay, so it works and we get the same values as before, and the sum is still 42. So the takeaway is you can either use the array indexing method to access and read or write values to the array, or you can use a pointer, or you can also use the combination of the two. So in exercise number 2, we first had a look at how to use the array indexing to update the values. Then we updated our code to work entirely with pointers. And then in this exercise number 4, we had a look at how we can use the combination of two, which is using the array indexing as well as using the pointer. So that was all for this video. Thank you for watching.